Namaste and welcome. Today we take you on a journey from the world of video games to the frontiers of geospatial intelligence. Yes, we are talking about graphical processing units, or GPUs, and how they have revolutionized the way we process and understand remote sensing data. A GPU is a specialized electronic circuit designed originally to accelerate the rendering of images and videos. Unlike a CPU, which may have a few powerful cores for sequential processing, a GPU comes with hundreds or even thousands of smaller cores designed for parallel tasks. Imagine trying to edit a high-resolution satellite image. A CPU does it step by step, but a GPU? It breaks the image into thousands of parts and works on them simultaneously. This parallelism is the magic that makes GPUs ideal for image processing, especially in handling large-scale remote sensing datasets. The GPU story begins in the 1990s with simple two-dimensional graphics accelerators for gaming. Soon, companies like NVIDIA and ATI introduced programmable shaders. But the real breakthrough came in the mid-2000s when NVIDIA launched CUDA, a platform that allowed general-purpose computing on GPUs. Suddenly, researchers in physics, chemistry and geosciences saw the GPU not just as a graphics tool, but as a supercomputer on a chip. Today, modern GPUs support deep learning, real-time three-dimensional reconstruction, and large-scale raster data analysis, all from your desktop or cloud environment. Remote sensing deals with images from satellites, drones, and airborne sensors. These images are huge, sometimes several gigabytes per scene, and often captured across many spectral bands. Processing such data, applying filters detecting land use or extracting features, takes enormous computational power. This is where GPUs step in. Whether it's a simple NDVI calculation over an entire country or a deep learning-based land cover classification, GPUs reduce processing time from hours to minutes or even seconds. Let us delve into some real-world applications where GPUs have truly made a difference. In image enhancement, GPUs accelerate the radiometric and geometric correction of satellite images. When it comes to classification, frameworks such as TensorFlow and PyTorch running on GPUs make land cover classification faster and more accurate than ever before. For change detection by processing time series data, GPUs help identify forest loss, urban growth, or flood impacts in near real time. In hyperspectral analysis, hundreds of bands can be analyzed in parallel, allowing for mineral detection, crop health assessment, or even pollution tracking. And in three-dimensional reconstruction and LiDAR, GPUs enable rapid point cloud processing for terrain modeling and urban planning. These tasks benefit directly from GPU acceleration because of their inherently parallel nature. Today, there exists a rich ecosystem of tools for GPU-accelerated remote sensing. CUDA and OpenCL allow you to write custom GPU kernels. With GPU bindings, GDAL can speed up raster operations. Envy and ArcGIS Pro come with built-in GPU support for image classification. Open-source tools like QGIS also support GPU plugins, and cloud-based platforms like Google Earth Engine utilize GPU farms at scale. So whether you are a student, a scientist, or a policymaker, GPU-accelerated tools are well within your reach. As satellite imagery becomes more frequent, higher in resolution and richer in data, GPUs will become even more essential. Emerging technologies like edge computing, where small GPUs are deployed on drones or field sensors, will allow real-time image processing without the wait for cloud uploads. Meanwhile, AI models trained on remote sensing data will run on GPUs to detect wildfires, illegal mining, or crop failures, all in real time. In the Indian context, with programs like ISRO's Bhuvan, NRSC's geospatial datasets, and the increasing use of AI in agriculture and climate studies, the integration of GPUs into geospatial workflows is not just a luxury, it is a necessity. To conclude, the GPU, once made for games, now plays a starring role in decoding our planet. From the pixel to the policy level, it is transforming how we see the world. Thank you for watching. Don't forget to subscribe for more on remote sensing, AI and GIS.